So I want to sort of talk about set theoretic realism and number. I want to talk about what set theoretic realism is, and what set theory is. I've been thinking about set theoretic realism more than just with respect to number and mathematics. And set theoretic realism has to do with set theory, and set theory is almost like a amalgam between mathematics and logic. It's mostly logic, I would still say. A set is a thing where we have these little bracket things here. That is considered a set. In that every set is a group of things. It's a collection of things. A a set is a things brought together for some certain reason. Like I could talk about the set of all red things. So set theory almost is also relates to talking about properties and talking about abstract abstract entities and stuff like that. In that when we talk about the property of red of redness, there's a set of all red things. When we talk about all warm things, there's a set of all warm things, but that's more on the broader scale. A set is just a mere collection of objects. We could just have a small set of things, which is the set of all things um, that are um, that are stinput, and we don't even know what stinput is. That's just like a gibberish word I used. Okay, a set of all things that are stinput, and we could say that stinput is a very narrow concept, and there's only a few things in the universe which do, which are that. Another thing is that you can have set theory. We have things like set membership, union, and intersection. Um, and we also have subset relations, like these. This is the membership, which would be saying that A is a member of B. Normally, this would be a individual. That's my bad. Um, this is intersection, which says that this whole thing here is the set of all things which are common to A and B, and this is union, which is everything that is A, and B, which is everything that is A, everything that is B. This is subset, which says that set A is a subset of B. And what does this have to do with realism? There are theories of mathematical logism, and that is that mathematical entities or mathematical concepts are reducible to logical concepts or logical entities, and we can talk about everything in the world, whether it be number or anything else, by making a set out of it. We can talk about anything in the world by using sets. And as to whether, well, if we're using sets and we're having a set theoretic realism, we're saying that first of all, a realism is that in philosophy is that is that entities are in this issue we're talking about number. Entities are objective, independent of mental input. If I were to close my eyes, the number 3 would still be there. um, and it's abstract. It isn't necessarily abstract. A Platonic version of realism would be abstract entities and concrete entities, like how the abstract color of green instantiates in this concrete entity of a pen or a pen cap. And why is set theoretic realism helpful to philosophy of mathematics? It is so because when we are asking questions in the philosophy of mathematics as to the foundation of number, we can say that number is something that is objective, mind independent, and we can talk about them, or and we can conceive of them via the notion of a set, and we can think about it in the ways in the idea of a set, in that the number 3, the set of everything that is grouped into threes, in a way helps us think about the number 3, and kind of in a way can give us food for thought of a foundation of number. Now, logicism, formalism, and intuitionism are all different foundations for number. My personal favorite is logicism, of course. I plan on arguing that more on this channel. I think I plan on talking about it a little bit more here. But I have talked about Frege a little bit, and I plan on talking more about Frege's Gridlogging in the hopefully near future. But I really do have a lot going on here, so we'll see. When we're talking about set theoretic realism, is just that the foundation of mathematics is also through sets. Mathematics are founded on the logical concept of a set, and we can even break down sets further into purely logical concepts. And a set theoretic realism says that, of course, number is a mind-independent, objectively real thing, and it is the foundation for it can be thought of in a formalistic way or a logicistic way. In this video, I want to think about it in a logicistic way, and I think that set theory is really helpful for that. The foundation of number is via set theory, whether we're talking about Cantor, Dedekind, Zermelo, Russell, or Frege, or whatever. The foundation of number is through sets, and thus through logical concepts. Frege did have himself a kind of a set theoretic realism, but I would say Russell did much more. In Russell's writings on number, including his Principia Mathematica with Alfred North Whitehead, I think he definitely had a more almost a more formal set theoretic realism, and showed in a way how the foundation of number is logic. So I've been thinking about set theoretic realism a little bit more, and I think I'm going to be talking about set theory a little bit more also. So if you think I left something out or messed something up, comment below and let me know. Thank you.